Alright, so in this problem, we're given a system where there is a ball sitting on a tee, initially at rest. We're given a bat that's swinging at the ball. So we're going to be given the mass of the bat, the mass of the ball, the initial velocity of the bat, and we're given the final velocity of the ball after it's hit. And we are asked to find what is the velocity of the bat after the bat hits the ball. So the first thing I'm going to want to do when solving this problem is make a list of everything that I know about the system. So the first thing I'm going to write down is the mass of the bat, which I know is 1 kilogram. So I'm going to call this m bat, and that equals 1 kilogram. All right. And the next thing I'll write down is the velocity of the bat initially. So I'll call this v bat, and I'll give it a little I for the initial velocity. And that's equal to 15 meters per second to the right. And in this system, we're defining right to be positive. Okay? And so the next thing I'm going to do is look at the ball. So the mass of the ball, which I'm going to call m ball, is equal to 500 grams. Okay? And the initial velocity of the ball is 0. So I'll just go ahead and write that down. Velocity of the ball initially is going to be equal to 0 meters per second. And the final velocity of the ball after the collision we're given in the statement is 20 meters per second. So I'll call this v ball, F for final. And that's going to be 20 meters per second. And this is again positive, so that means it's traveling to the right, which is what you would expect. Okay, so looking at this problem, I can see that I have the mass and velocity of the bat, the mass and velocity of the ball, and I have the velocities for the ball before and after the collision. So the first thing that pops into my head is the relation I know for conservation of momentum. So I'll go ahead and write that out. So for that system, this would be the mass of the bat times the velocity of the bat initially, plus the mass of the ball times the velocity of the ball initially is going to be equal to the mass of the bat times the velocity of the bat, F for final after the collision, plus the mass of the ball times the velocity of the ball sub F, so after the collision. So I can see in this relation, I have all of these terms except for the velocity of the ball, or sorry, the velocity of the bat after the collision, which is what I'm looking for. So I can rearrange this equation to solve for that. So the first thing I want to do is look and see if I can simplify this in any easy way to make my life a little bit easier. So I first see this here. So the velocity of the ball initial, I know that's 0. So I can go ahead and just cross this completely out and not have to deal with it at all. And the next thing I'm going to want to do is I want to isolate the velocity of the bat after the collision so I can solve for it. So what I'll do is I'll subtract the mass of the ball times the velocity of the ball final. So that goes away, and it's going to come over here to this side. So I'll have the mass of the bat times the velocity of the bat initial minus the mass of the ball times the velocity of the ball final after the collision is going to be equal to the mass of the bat times the velocity of the bat after the collision. So I almost have the velocity of the bat isolated, which is what my goal is. So the next thing I want to do is divide by the mass of the bat in order to solve for the velocity of the bat. So after I divide through by the mass of the bat, I'll just do this right here. Mass of the bat, this cancels, and we're going to get the velocity of the bat initial minus mass of the ball divided by the mass of the bat, I'll put that in parentheses, times the velocity of the ball after the collision equals the velocity of the bat after the collision. So the term we were looking for is now isolated, and everything on the other side of the equation are knowns. So we can plug all of these in, and we can get a numeric answer. So I'm going to take this over here and just plug in what I know. So the velocity of the bat, what is that? The velocity of the bat initially is 15 meters per second. So put in 15 meters per second, and now I want to subtract the quotient of these two masses. So what I realize here is that the ball and the bat are in different units of mass. One is in grams and one is in kilograms. So what I want to do is convert both of these to kilograms so they're in the same unit. So the ball is what's in grams, so let's convert that to kilograms. So what is 500 grams in kilograms? Well, 500 grams is a half a kilogram, so I'm just going to call that 1/2 kilogram. And that's going to be divided by the mass of the bat. The mass of the bat is 1 kilogram. Okay? And now we're going to multiply this by the velocity of the ball after the collision. And what is that? That's 20 meters per second. And that'll give us our answer. So before we do any computation, an easy way to check to make sure you're on the right track is to see if your units are going to work out right. So we know we're looking for a velocity, so our units should be in meters per second. So we can see here, kilograms will cancel, so this will just be a constant. And then we have meters per second and meters per second. So that checks out. We're going to get an answer that's meters per second. So let's go ahead and carry out this computation here. So this will be 15 meters per second minus 1/2 divided by 1 is just 1/2. So this will be 1/2 times 20. What's 1/2 times 20? That's 10. So 10 meters per second. What is 15 minus 10? That's going to be 5 meters per second. Okay? So we have found that the velocity of the bat after the collision is going to be 5 meters per second to the right.